Okay, advanced math students, this is a quick little video just to give you a little bit of background heading into the spherical navigation guest speaker that we have tomorrow. Mr. Bright is going to be coming to talk about how sailors navigated around the globe for years using math that you are, I think, pretty familiar with. Just a couple of quick reminders. So here's our sphere, okay? We're going to consider this the sphere of the globe. And what you just need to review really quickly, because he's going to refer to these terms, is that the horizontal lines that run around the globe, okay, you need to remember that those are called latitude lines. And latitude lines are going to run parallel to each other, to use that geometry symbol there. And because they're parallel to each other, they stay equidistant. Second thing you need to be aware of is that these other lines that run vertically from North Pole to South Pole here, those are, of course we know, longitude lines. And they are going to be vertical lines instead of horizontal. The way that I think about it is if you deal with latitude, you think of the rungs of an actual ladder, right? So the rungs are parallel to each other and run horizontally, and that longitude is the vertical lines, and they basically have the same long length from pole to pole. We do need to be aware, though, that they do not stay equidistant. Can't write, sorry. Because if you think about where those lines get closer and closer to the North and the South Pole here, and you can see on the globe themselves, the lines actually kind of converge close together as they get close to the North Pole. So that's the first thing, just a quick review of latitude and longitude there. Okay, so the second thing you need to be aware of is a discussion we're going to have about what's called the celestial sphere. And in the celestial sphere, the entire Earth is just the center of that sphere. It's contrary to what we know of astronomy now, that nothing revolves around the Earth, but I know you guys probably like to think the world revolves around you, but it doesn't. But in spherical, in the celestial sphere, we're to assume basically that the Earth is the center of this bigger sphere. So let's shrink it down. Shrink down the Earth so that it's as close to a tiny little dot as we can get. And then we're going to draw a sphere around that. Okay, so again, let's zoom back out. We'll get back to our globe here. And if we draw, let's just say, quick little United States here. Okay, then of course we know we've got ourselves right here in Cumberland in Maine. And in the celestial sphere, excuse me, as we shrink the Earth down, what we need to be aware of is that that tiny little dot that we made for Cumberland, it projects its position out onto the celestial sphere. So this is a sphere in space, okay? And basically, since the Earth is the center, it projects an image of wherever you are on the Earth directly above you out to this celestial sphere. So here's Cumberland's spot on the sphere, okay? And that has a word called, it's zenith. Z-E-N-I-T-H. The zenith of an object is its position out on the celestial sphere that's directly above where they are on the Earth. Because remember, the Earth has been shrunk to the center of this sphere here, okay? So it's kind of like a glow pet, if you think about it. When you put a glow pet in your bedroom and turn the light bulb on, it projects its position out onto the walls, right? So all these little things go out onto the walls. But what we're saying is that all of these stars are exactly equidistant from the center of the celestial sphere, which is the Earth. Hope that makes sense. The most important zenith that we are concerned about in celestial sphere navigation and spherical navigation is the zenith of the North Pole, okay? So the North Pole zenith out on the celestial sphere is pretty much located exactly where the star of Polaris is. The star of Polaris has a zenith that stays pretty much consistently directly above the North Pole, and that's year long. And that's why it's known as the North Star, and why sailors for years have used it, for thousands of years, have used it to navigate because of its kind of consistent position. So I hope that gives you a little bit of context for where things are going to be at tomorrow in our presentation. We look forward to having you guys learn a little bit more about the world of navigation from somebody who's very knowledgeable about it. See you tomorrow.